with Rob. Oh boy, I have to
So
say,
we consider. I'm saying though, we
second
consider
time
sea
this
level
evening
the
that I
horizon.
agree.
Yeah, we
Second
consider
time.
ourselves like the
Only hear one
observer
voice
and
at
the
a time.
horizon are both sea level, and then we remove the observer height down to that right to that sea level, and that gives us 0 degrees from the wherever we're aiming all the way to where we are, and that's our measurement right there.
That's really a remarkable
That's our
evening.
flatness. It's zero
First in the
degrees.
evening, first in the evening, I had to agree with Torah. Now I have to agree with Rob. So that's really I have to make a red mark in my calendar.
Thanks, dude. I appreciate that.
You see, sea level. That's easy. You have altimeters that do that.
You don't even know if you got high tide or low tide,
That was
Rob.
the most ridiculous thing
Utah.
I ever heard.
Yeah, I mean, yeah, you adjust for tides.
You
Tides
got you
change.
got high tide or low tide over there in Jamaica.
It depends on what time of year.
Oh, you guys actually do get high tide and low. I thought you guys don't get tides over there.
Oh yeah, big time. We're talking about sometimes you go to the beach and the impact on the beach is higher. Certain time of year. So
Is that true
great
though?
time.
Because I heard like Jamaica was one of the places that doesn't have like high and low tides.
Yeah, man, them have tides. The moon is everywhere, and the moon affect the tides.
You just got to be right near the beach, boy.
The moon,
I
the
mean,
moon,
can anyone confirm that? Is
the
there
moon
another
cause
glober in here that can confirm Jamaica having high and low tides?
I think I just checked if it's correct. The high tide and low tide for today would be something like 40 centimeters difference. So it's roughly a feet or so, a little bit more, a foot.
it varies throughout the year because we have the moon. Remember the moon. The moon causes your tides.
All right. Well, I'll let it go, but I'm pretty sure I've always heard Jamaica is like one of the few places that isn't
I think
affected by tides.
I think
Also,
Jamaica's like Spain. It has minimal tides.
Yeah, no, wait a second. You have to check where in Spain. If you look to the Mediterranean Sea, that has a totally different reason. I mean, just like the point at Gibraltar is just not possible to let so much water in. That's why the Mediterranean Sea has basically no tide. But Jamaica is in the open ocean.
so are you saying that the tides are um, less, I don't know, for lack of a better word, volatile than other shorelines in other parts of the world? You saying it's
In the Mediterranean Sea?
no, or Jamaica?
Ah,
Well, Jamaica is on a larger ocean. Remember the Caribbean Sea is part of the Atlantic, and it's open. It's bigger, unlike the Mediterranean, which is more enclosed. So you have less tides in the Mediterranean.
Yeah,
You
but we've
understand?
got we don't just have the Mediterranean, do we? We have the Cantabrian, which is on the north.
Yeah, we have a lot of bodies of water that is enclosed, and those don't experience tides very much, if at all. You understand? Is the larger the amount of body of water, is the more tides you'll have because of the moon's gravitational impact. Clear.
example, in northern Germany or like west coast of Scotland. So, for example, in Germany, you can walk to an island during a low tide, and where then there is high tide, there are boats passing away. So, same in Scotland. There are times when you can walk to the island, and then there are times you can't because they have 4 meter tides difference. For example, I think as often I posted a map, and the Caribbean looks pretty low affected.
Well, I'm looking
Yeah,
at
the
it.
Caribbean is that. Oh,
Well, I'm looking at one that shows. Well, it's got these different color codes. I'd have to see what. Yeah, maybe the ones yours is similar, but the whole Caribbean area on the one I'm looking at looks. I guess it's like this dark blue color, which is pretty strong tides.
But dark blue is strong. So on my map, blue is very low.
Oh, okay, then I have it mixed. I have it backwards. Sorry. Yeah, I was just looking at this. This one's
Remember,
kind of.
Yeah, I
remember
think
it's a volume of
Jamaica.
water. It's a volume of water over um, a much larger surface area that
So
piles up and piles up and pushes the tides more in. So lakes don't have that much such a large surface area. So the water, by time the moon completes that transition, over the lake, there's not much body of water that
yeah, okay,
piles
but
up on each other to rush up the sides.
Jamaica is not in a lake. But there is one
I
map
know,
that
I
I
know. I'm
posted,
just
and then there is another map, an animation that Rixky posted. And in my animation, it's the amplitude. So it shows in color the maximum difference between high and low, between 0 meters and 4 meters. And Rixky then posted an animation over time where blue is minus 1.5 and red is plus 1.5. So I think there's the difference. But there are areas like the Caribbeans which are barely kind of going out of this, what is it, yellow zone or so? Yellow greenish zone.
big man. There's a lot of tides.
Well, then
In,
that's why. Wait, you're saying there's a lot of tides in Jamaica? Like this is the
yeah,
one from. Well, maybe you're saying something different. Well, this one's from just the Wikipedia for Amphidromic points, and it's interesting because it is very dark blue into where Jamaica is, but on the other side of Cuba, because that's more where I've been. I've been on the, I guess, like north of Cuba in the Caribbean, so there are tides, more tides there, and even that map shows it. It's like light blue on that side, whereas it's dark
Yeah,
blue.
because Cuba is in the fence with the Atlantic Ocean. Jamaica is in the Gulf of Mexico, so it's more inner into the Caribbean Sea instead of the ocean. So
Right.
Jamaica is is behind the wall of the ocean, behind under Cuba, under Dominican Republic, Puerto Rico. Those ones are at the edge of the Atlantic Ocean. Jamaica is behind that wall.
Yeah,
yeah.
I
And
think
Right,
the
and then you've
idea.
got
remember,
there's the
Caribbean.
Panama Canal, so that's all like fairly shut off there. So that makes sense. The water's not going to flow the same as it would like when it's more
correct.
front of the
So
ocean.
You
so
would have some strong
smaller.
current.
So the smaller the body of water. So you have lakes, then you have seas, then you have oceans.
Yeah, okay,
Oceans,
but
more tides, like off of the
Thank
coast
you
of
for letting
Africa.
me know.
that's
Caribbean,
not entirely true. That's not entirely true. Often, for example, you see on the coastlines, for example, West Europe coastline,
yes,
or as you see Alaska, or then on the west side of what is it, Central America, you see kind of very high amplitudes. But the Gulf of Mexico, you have very small tides, but you should have a pretty high current kind of water going there, maybe. I mean, it's not just like the amount of bodies of water. It also has to do with the depth of the sea at that point and so on.
Remember that
Like, imagine-
animation they used to show us of like the bulge coming out from either side of the Earth? Neil deGrasse Tyson talks about. I don't see this bulge. Like these tides don't work. What happened? Like that animation has nothing to do with this sort of consistent bulge that's rotating around the Earth. Something else is going on for sure.
No. See, the bulge stays still, and then the Earth rotates into the bulge.
Oh yeah, I forgot about that one. That little part of it too.
hey man.
How does the bulge get past America? Like the whole continent of America seems to go from north to south and just bypasses that somehow. Jamaica gets in the way.
Refraction.
Again, the Earth is 70% water. You have to remember that. So the bulge
What
is
does that got to
really
do with it?
the bulge is really at the Atlantic and the Pacific more. You understand? So yeah.
The bulge should be around the equator. Where is the Jamaica? Around the equator.
No. That bulge is different. That's a different bulge.
How many bulges have you got?
That's a different bulge.
Mate, you're kidding yourself.
The centrifugal force. You know,
Centrifugal bulges now?
yeah, that's what happens at the equator. Yeah.
There's a salad of words going on.
Do
I'm feeling it.
you weigh about 3 pounds less at the equator? You know that, right?
Huh?
Yes, you weigh
Oh,
about
yeah,
3 pounds
yeah,
less.
yeah. Just
If you
shipping
live
is spinning.
if you live in
Absurd.
Kansas,
Absurd.
right, and then you move and you weigh 100 pounds. If you go to the equator, you're going to weigh about 97 pounds.
I think that is a little
Remarkable.
bit too. This is a bit too much, actually.
What? It is about 3 pounds. Well, okay,
I
I'll
think
have to
I,
Google.
I think it is. I think the difference is more like 0.3 pounds. Robert.
Shouldn't you
Oh,
haul?
it's 0.3. I'm sorry. I thought it was 3 pounds. Right, it's 0.3.
Shouldn't you haul your gold up north? Then you could haul your gold from the equator up north and make
What
a
you
bunch of
should
money.
do. Except they usually use mass for gold, so
Yeah,
that's
but
I wonder.
but
I wonder if I wonder if the MMA has like a sliding metric scale depending on where they host their events for their fighters for them to
yes,
make
they have.
weight. Like, oh, this event's going to be on the equator, so you
No,
guys
not
gotta
the
you gotta
MMA. Not,
sandbag
but
3 pounds.
no, the MMA not. But gold scales have to be calibrated to the position on Earth, to your latitude.
Where do you get this shit from?
No,
Where'd
that's
you
that's
get?
that's
Dude,
and
then
here's
actually
they
true.
recalibrate it once it gets to the location. So that's
Yes.
completely blown out. That's just stupid.
well,
Did you
here's
No.
look up
another
that
one.
one, the gnome study where they send the gnome, they fly the gnome all around, they weigh it in all these places, and it doesn't match the freaking globe model at all.
Critical
Here's here,
Thing did that again during the final experiment, and it absolutely matches the globe
yeah.
model with the weight differences. And it's not made up shit. You have to calibrate fine scales that are in this area to your location with some calibration masses so that it actually measure the mass and not the local weight.
And here's another thing that'll blow your mind, or that you'll just be able to laugh at us about. If you weigh yourself on a plane that in level flight flying east, you will weigh measurably less than if you do the same thing in a plane flying flying west.
That's
Well,
what my fat girlfriend.
I can tell you this, man. It's just so absurd.
Told you.
My freaking globe model at all.
Critical
Here's-
Thing did that again during the final experiment, and it absolutely matches the globe
Yeah.
model with the weight differences. And it's not made up shit. You have to calibrate fine scales that are in this area to your location with some calibration masses so that it actually measure the mass and not the local weight.
And here's another thing that'll blow your mind, or that you'll just be able to laugh at us about. If you weigh yourself on a plane that in level flight flying east, you will weigh measurably less than if you do the same thing in a plane flying flying west.
That's
Well,
what my fat girlfriend.
I can tell you this, man. It's just so absurd.
Told you.
My
Do the same thing in a plane flying flying west. Laugh at us about. If you weigh yourself on a plane that in level flight flying east, you will weigh measurably less than if you do the same thing in a plane flying flying west.
And it's not made up masses so that it actually
Flying east, you will weigh measurably
scales that are in this local weight.
And here's another thing that'll blow your mind, or that you'll just be able to laugh at us about. If you weigh yourself on a plane that in level flight flying east, you will weigh measurably less than if you do the same thing in a plane flying flying west. If you weigh yourself on a plane that in level flight flying east, you will weigh measurably less than if you do the same thing in a plane flying flying west. At us about. If you weigh yourself on a plane that in level flight flying east, you will weigh measurably less than if you do the same thing in a plane flying flying west.
That's
Well,
what my fat girlfriend.
I can tell you this, man. It's just so absurd.
Told you.
My goodness. I know. Yeah, I'm gonna say it's all absurd. Absolutely. And the thing is, you're going to take those scales and you're going to recalibrate them when you get to the position. So any latitude or longitude crap that they did at the place where they made them is completely irrelevant. You're going to calibrate it when you get there, because that's what you do with something that's really, really, if you're talking about some highly precision thing, not a bathroom scale,
Well, that's why you really want to use, a balance scale if you want to really see the difference. You balance something of known weight, all right, against something that's been determined at some latitude. If you balance, you have a 1 pound thing or something. It makes a difference, right? If you use a spring scale, it'll change, but if you use a balance scale, you'll get the right result, because the difference there is you're measuring the mass. You're really comparing the masses, not the weights.
Cocaine dealers use
Hey,
quad or
please.
triple.
I just want to say, this guy's talking about using a balance scale on an airplane.
No, I wasn't. I was talking about using a calibrated spring scale. It doesn't even have to be calibrated. The point is there'll be a few tenths of a pound of difference between flying west and flying east.
John.
What's the control? What's the control for that experiment?
Well, I'm not sure what you mean. You take the same person. You could take many different people and see how much difference you get from all of those different people. That's all you do.
Yeah, the control is that you fly in the opposite direction. This is your control. You fly west, you measure. You fly east, you measure, and you can repeat that multiple times.
How about with the aircon as well? That's going to make a difference.
Can you come again? You were breaking up.
Right. Air conditioning is going to make a difference. I can verify that because I've had the same problem.
Temperature of air definitely makes a difference in weight measurements. Maybe not a big one.
It's not about the temperature of air. It's about the air coming in and the air going out. So it's the sucking, and because I have a room and it's a controlled room, and if the aircon is blowing in the room, the scales are different. If it's sucking, it's different.
Yep. So this is
work in my face.
let's consume it to the density of air. That can be either due to temperature differentiations or under pressure and over pressure.
It's not about density.
Yeah, if you create an under pressure in the room,
it's about the air coming in the room and the air leaving the room.
Yes, if you pull air out of the room, you are creating a lower pressure in the room. Therefore, you're reducing the density of the air in the room. If you push air into the room, you're creating a higher pressure in the room. Therefore, it's causing a higher density. And higher density medium causes a higher buoyancy. That's why you weigh less in water than you weigh, on a scale in water, than you weigh in the air. Or in a vacuum, you weigh even more.
But just to make a criticism on you telling me you weigh one way and when weigh the other, that's not correct, because if only half the people put the aircon on one way and not the other, that's going to be different. It's not a control, is it?
I don't really get how your air conditions work, because here if we have air conditions, we have these split devices, so they are not putting any air inside or outside. But
okay, so you got the air condition, you got the air blowing into the plane. You got there's three. Say you got 3 seats, there'd be 3. So if you open them all up, the air coming into the aeroplane is going to be stronger. But if half
a certain direction, just
he put for G, and then we just multiply those, right?
I think
what G for let me in a vacuum.
Is there a reason why he used W?
So it doesn't work. So if we're being honest, it doesn't work on Earth where we live. It only works inside of a vacuum.
It's not that it doesn't work. And the point is it's obvious. It's obvious that you understand
Be honest, John.
I'm being honest. It's obvious
Doesn't
that
sound
you
like it.
understand it. So why are you trying to make this sound like there's something crazy going on? The weight of an object can be, you can define that in many ways. You can define it as the reading of a scale, in which case, of course, you have to realize that there is a buoyant force affecting your weight.
John.
If you want the weight to be the acceleration due to gravity, which is what a gravimeter determines, if you want it to be that number times the mass of the object, and you want the scale to read that, then you're going to have to do the measurement in a vacuum.
Yeah, so if we were going to be honest right now, if we were actually going to be honest, like you wanted to do at the beginning, you would say, yes, Jeremy, it doesn't work on Earth where we live. It only works inside of a vacuum, inside of a medium that we don't live in.
Dishonest attempts to turn this into a gotcha are perfectly obvious.
It's not a gotcha. It's just, I'm just pointing out that your formula doesn't work and you don't want to be honest with me, even though you started this off by saying, let's be honest.
Formula works perfectly.
It doesn't work at all. I can give you a demonstration. Hold on, Snooze. It doesn't work at all. I can give you a demonstration of it not working. And then
no, you can't. You can give me a.
That's where you say we got to go to a vacuum, which is where we don't live. We don't live in a vacuum.
You can give me a demonstration. Right, you can give me a demonstration.
Medium that we don't live in. You can't be honest.
You can set up a thing to make your point. I understand your point. I'm not saying you're wrong. I'm saying you're being dishonest.
You're incapable of being honest, John. This is so slimy and disgusting. It's unbelievable.
But Jeremy, the weight of an object does not change if you are in neutrally buoyant. It's not changing the weight because the weight of the surrounding gas has the same weight. But if you're moving towards east or towards west, your actual weight is changing because little g is changing. That is the difference.
Well, hold on. But the momentum of the Earth.
Yeah, due to the rotation of the Earth, little g changes.
Changes, right? Exactly.
It's not 9.8 meters because you have a centripetal force, and then you have also the centrifugal force that you have to subtract from that gravitational force. So in this equation, the value for little g changes. While if you are in neutral buoyant balloon, your scale shows a different mass because your scale is not working properly due to the surrounding buoyant forces.
Right.
That is a different observation.
Yeah, the Earth's momentum is kind of giving you a little bit of a slingshot upwards. So that's why the gravitational impact is a little different if you're going east. But why are you saying W equal mg and not F equals mg? Why are we doing that?
Because W equals mg is the weight due to gravitational acceleration, and F is the force, and that can be without any kind of gravity acceleration. It can just be acceleration times mass. That can be upwards, that can be sidewards. That has nothing to do with gravity. That's the only differences.
No, I understand it. I'm just thinking. I'm wondering if he's trying to do a kind of a gotcha kind of thing. I'm just trying to understand why he just said, "Hey, W equal mg."
So I just did a little calculation. It's an easy calculation just based on the centrifugal effects. And I find that if, for instance, if the acceleration due to gravity on the ground at the equator was 32 feet per second squared, then it's going to be 32.1 feet per second squared in a plane going west and 31.9 feet per second squared in a plane going east. There's a difference of about 0.2 feet per second squared, which is a difference of almost 1%. So it makes a difference of almost 1% in your weight, about 2/3%.
What velocity or speed of the plane did you assume?
What I did was I assumed a plane traveling due east at the equator, so it's being carried at 1,500 feet per second by the rotation, and then an additional 700 and something by its own speed. That makes it go about 2,200, 2,250 feet per second when it's going east. Whereas when it's going west, the two subtract, so it only goes a little under 800 feet per second squared, and then that per second, and then the v squared over r difference that you get between those two is about 0.2 feet per second squared, which is about 0.2% of g.
And that was for sea level.
Actually, I put an additional 8 miles into the radius, but it doesn't actually depend on whatever you want to take for your base g. You just add or subtract about 0.1 feet per second squared for a plane going 500 miles an hour.
All right. Well, let's keep it going. I think maybe some of the people that were in the last combo. Looks like Jeremy is not he left the VC, so I don't know. Should we do a new topic or?
Did he melt down or is he busy?
With thought experiment. I have a thought experiment for all the Globers if they're willing to entertain it.
Go ahead.
I want to create a 400-meter horizontal slab of concrete. Is that possible in reality?
It's going to cost a lot of money, bro.
With content.
In my opinion, with enough money, yes.
Well, once again, I think with this crew, we need to be careful to point out that there will be tolerances on that, right? I mean, you can't do it perfectly. No, nothing's possible if you want to do it perfectly.
And you're talking 400 meters of perfectly planar concrete.
Well, then
how many square feet is that?
No, you can.
Are you saying there's an imperfect way to make a baby?
1,200 feet concrete.
But it has to be perfectly flat. So the answer is no, you can't do that.
Yeah,
I mean, the biggest references I've seen are like these large industrial facilities down, because I'm here in the Midwest and we have this BNSF hub where there's about 8 or 9 million square foot warehouse facilities that are just monstrous. And even those, you don't have one solid slab on the floor. Any big building, you're never going to have one solid slab. They have those tension breakaway points on them, even on smaller like concrete sidewalks. But I mean, that's about as they've got some that are bigger than that, like the Amazon facilities and things like that. So those are references, I guess.
I mean,
they're all level
you
though,
can,
not flat.
You can make that, for example, this concrete a plane, as long as you kind of have it on some kind of bearings or so that temperature extensions can extend, and maybe it will crack after some time due to internal kind of tensions or so. And yes, I totally agree with John. There is a margin of error, of course.
What they do is they'll float the floor and try to get it as flat as possible, and then they'll get a latex. It's like a self-leveling concrete. It's like a latex thing, and they pour that, and it will go as near to level as possible.
Yeah, but you would still have to vibrate it. But
no, you don't do that. The vibration's on the slab, so you lay the slab, and then you'll float it.
Yeah.
And then what will happen? You'll build up around the slab, and then you'll pour the self-leveling concrete.
But also self-leveling concrete has to be kind of distributed with these kind of needle rolls or stuff like
That's
that.
it. That's why it's called self-leveling.
You don't need
There'd
to
be a limit to
vibrate
how big an
anything. It's
area
only
that would work across, right?
That's why it's a latex thing. It will
So-
go into the slab, or they will pour. That's when you have the vibration stuff, when they come in and they'll have like I can't remember what they call it, but they pour the floors, they put the vibration in, and then they will float that. But like really and truly, if it's something like a warehouse, they'll pour the self-leveling stuff, because they need that, because it's people walking along, and on the other things is smaller, so you're doing room by room.
I do know, and I also do know self-leveling, but the most self-leveling toppings that I know, I don't know one where you don't have to do that. You have to help it to level. For example, by applying these kind of needle rolls or some other agitation of these things to actually level, because it's not as liquid as water or less. And
Yeah, it's
even
like
water, if you spill water, it has some surface tension. Therefore, it creates kind of bulges at the end or so. So it's not 100% the leveling itself. It creates, you know what I mean? So you have to still distribute it or make it
That's the
thick enough.
next part he's trying to explain to you that you're not listening.
Yeah, they distribute it with like that. It's like a big squeegee. Self-leveling. That's why it's a latex thing. It's got latex in it, I'm sure.
So Rob, this was a thought experiment, you said. So what was that? The completion of it? Was it just making a level slab of concrete, or was there a second part?
Multiple parts, but as soon as I started, everybody kind of wanted a piece.
I didn't get that.
Yeah. So let me start again. I asked if it's possible to create a 400-meter slab of concrete and do our best to make the surface as horizontal as possible. Right?
Of course, you can do your best, right? Of course, you can.
Right. So, and then we take a walk. Yeah. So, are you guys going to let me go through the thought experiment and then address it, or do you want to just keep jumping in the middle?
I just wanted to clarify one thing, because Schlitzy was talking about something that is self-leveling, and if you want to create a horizontal thing over 400 meter, maybe you have to do something against the leveling, because then it could be off from the horizontal behavior.
So Snooze, you meant yes, you do want to interrupt him in the middle of what you're saying. Not no.
No, I want to know if it's even possible to create a 400, let's say 400 meters by 1 meter. So we're making like a sidewalk, right? But I want it solid, 400 meters horizontal first. Like if we got to dig out some of the ground or whatever, you know what I mean? I want it horizontal, sidewalk, 400 meters. Can we do it?
Within reason, yeah. It won't be directly like 100% level though, for sure. And worked on big slabs, and they're power floated them, and they say they're level. And then what we have to do, we have to lay a sole plate, and that sole plate is always going to be packed up, always. And the tolerance is 25 mil. You can't go over 25 mil.
Well, and I think that the simple thing is it's a lot easier to create a level surface than it is to create a horizontal surface.
Well, how do you know the difference between the two?
Over 400
meters anyway.
Well, you may not know the difference over 400 meters. Yeah, you may not care.
So we can't do it.
I would not say that we can't do it. Over 400 meters, we would have a difference in height of 3 millimeters.
Okay, wait. Before you continue, so a horizontal is no part higher or lower. So I don't even want 3 millimeters difference at one end to the other.
You're not willing to accept 3 millimeters, you're saying?
No, No.
Well, then it'll be
I want
hard
more
because, yeah, then it's
So
hard.
it's not hard or it's impossible.
I
I
wouldn't
think
say
that
it's
would be.
impossible. I would definitely not say it's impossible because there are high precision industry rooms that have a very low margin of error in height. And
Yeah,
I
that's
think
what I'm looking for.
that's why I said if you have enough money. With enough money, I would say you could definitely do a 400-meter long thing within 1 millimeter of margin of error.
Okay, perfect. Okay,
Are you saying
I'll put
level
1
or
millimeter.
horizontal, Snooze?
Horizontal.
Horizontal. Like guys,
Okay,
but tame yourselves for a
Snooze is
second.
totally wrong.
I'll back
Am
up
I
a
wrong?
minute.
Quickly, enlighten me.
Yeah, you're
You're,
yeah. We
$93 million miles away. But
Yep.
they're different. Different, yeah, in some ways, yeah.
Oh, you actually have a moon dial.
Yep.
We had something going with that before with the length of the shadows or something. Should be different. If they were the same, it would
Well,
debunk the globe or something.
well, there's the thing of doing the Eratosthenes sticks and shadows with
That's
moonlight,
it.
with moonlight instead of sunlight.
Yeah, that was
If you do, so if you do it with moonlight and you get the same angles, what is this? Moon also 93 million miles away? But
Yep.
Yeah.
of course, all it has to be is far enough away to produce parallel light, and it doesn't. The moon's not quite far enough away to do that as accurately as the sun, but it's really far away, so it does it pretty well.
But why would it give angles of 93 million if it was only a quarter of a million? Why
I
would
don't
it
know
give
what you mean by angles of 93 million. What do you mean? What matters for the Eratosthenes experiment is that the sun is far away, and the Greeks were well aware that the sun is very far away from the Earth. That's obvious simply from the fact that they knew pretty well the distance to the moon. That's just a parallax measurement. And then they knew that the sun was much further away than that because of looking at the phases, working out the triangle. When the moon is at first or last quarter, you know that the angle between you and the moon and the sun and the moon is 90 degrees. So you can work out the rest of that triangle, and you can show very clearly that the sun is much further away than the moon, which is itself very, very far away. And so the light coming from the sun is parallel for all intents and purposes. And the Eratosthenes experiment made that assumption because it was well founded.
Okay. Well, I mean, whether you make a judgment call that an assumption is founded or not, I guess would be subjective. But so you're saying the moonlight is also parallel? That's
pretty
what
close. I mean, it varies. It varies by what is it? A couple degrees, a degree or two, I think, from one side of the Earth to the other.
What's your account for those, like you know, like when the sun sort of goes through the clouds and it's
I started doing it
for people, but obviously you're very interested in the topic. So it doesn't really fit psychologically that you would just be like this like virtuous person that's just trying to help these people that don't think of something you think is right. There's obviously something more, but we don't have to get into that whole combo. I'm just saying
That's okay. No, I my wife says the same thing to me, right? She doesn't understand why I do this. And I started doing it. I think it's a different thing now. coming toward you. They're coming almost exactly toward you. In fact, many times you can see those rays passing on all sides of you. Some rays will go up, some rays will go down, but they all converge back at the sun. All of the rays that you see in the Earth's atmosphere are parallel to within a tiny fraction of a degree. They're just passing you at different distances.
So
and in
even
different
though
places.
they look like they're like fanning out,
Right.
they're actually straight.
Well, they are fanning out from your perspective, just like a railroad track does, right? Railroad tracks are parallel, but they look like they fan out too.
Oh, now I get it.
If only that were true.
It's like reverse psychology. No, okay.
But not to get into a whole meta thing, John, but I mean, you're saying that as if you're here to like try to just like teach or write the way for people, but obviously you're very interested in the topic. So it doesn't really fit psychologically that you would just be like this like virtuous person that's just trying to help these people that don't think something you think is right. There's obviously something more, but we don't have to get into that whole combo. I'm just saying it's
That's okay. No, I my wife says the same thing to me, right? She doesn't understand why I do this. And I started doing it. I think it's a different thing now. There's a lot of motivations. First of all, I started doing it because I feared, and I still do fear, that it's pushed by the same bad actors who push Pizzagate, all of the conspiracy things. They're all intended to make us fight with each other, to make us not believe authority, to make us not believe academics, to not believe experts of any kind, to not believe government, to not believe all of those things work very much to the advantage of people who I think do push these conspiracy ideas. So that's why I started it. I just wanted to stamp it out. I continue to do it partially because I think there's usually people in the audience who need to at least hear both sides of the argument and make their own judgments. Hopefully, if they're rational people, they'll make the right decisions. But there's also, frankly, the most important thing about it is it's made me look at a bunch of things. You guys have stimulated me to look at things that I hadn't looked at very carefully. One of the most, and I'll just give you one example, then I'll stop yammering, sorry. Aries failure. That's one thing that I had never heard of before. And looking into that has been a true revelation for me, understanding things that I never really did fully ground before, and just the whole history of 19th century physics that led to relativity is totally fascinating. I'm doing a room on it tomorrow, the first of many rooms that I'll be doing on Clubhouse tomorrow.